the 6.1 quiz. And they give us a sequence over here, okay? A sequence can either be linear, quadratic, or cubic, okay? If the sequence is linear, that means if you subtract every number, okay, if you subtract every number here from each other, all the numbers you get from subtracting, which we call it the first set of differences, all the numbers you get over here, the set of differences, is going to be equal. If it's quadratic, these numbers are not going to be equal, but if you subtract the differences from each other, you will get a set of differences, the second set of differences, that is equal, okay? And that's when it's quadratic. If it's cubic, the first set is not cubic, the first set is not equal, second set is not equal. You have to subtract every number in the second set again to get a third set of differences, and that third set is gonna be equal. So we'll check for this one. They said in W is the sequence of differences between V. So the first set of differences, when we subtract each number in V, we're gonna call it W because that's what they said to do. So the first set of differences is gonna be W. We subtract each number by the number before it. So 11, there's no number before it, so we skip it. We always skip the first number. 15 minus 11 is 4. 23 minus 15 is 8. 35 minus 23 is 12. 51 minus 35 is 16. 51 minus 35. 71 minus 51 is 20. 95 minus 71 is 24. And then 123 minus 95 is 28. So each number, when we subtracted it by the number before it, we got the first set of differences. And the first set of differences, as you can see, they're not equal. Okay, so we check for the second set of differences. Okay, the second set of differences, we do the exact same thing to this set now. Okay, so 8, we always skip first number. 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. 20 minus 16 is 4. 24 minus 20 is 4. 28 minus 24 is 4. So as you can see, the second set of differences is equal. If the second set of differences are equal, that means this sequence is quadratic. Okay, so go to the options we have here. W, which is our first set of differences, is equal to 4, 8, 12, 16, 20, 24, and 28. 4, 8, 12, 16, 20, 24, 28. So that is correct. This option is correct. The difference between any two consecutive terms of V is the original equation, the original sequence. V is this one. It's saying that the difference between consecutive terms, consecutive means after each other. The difference between everything after each other in V over here is constant. That's not true, because when we did it for V, the set of differences for V was not constant. So that one is not true. The difference between consecutive terms of W, which is the first set of differences, when we did the difference between the set of terms of W, we did get a constant. So it is true. This one is true. W is linear. Linear means the first time you subtract, the first set of differences is equal. If we take W as its own set, when we subtract all the values of W, we got a constant from the first time. We didn't have to do it again, which means that the set of W is linear. But the set of V, the one that we used the numbers from, the original sequence, that is not linear. It was quadratic. But W is linear because we immediately got the constant after W. And V is quadratic, we know that. Okay, هلا to find um هلا um the general rule for a quadratic function is an squared plus bn plus x. That's why it's called quadratic, because it's the same, its formula, its general term is the quadratic formula. So to find a, the first term in the sequence, you do 2a equals to the second difference. When we say second difference, I mean the first number of the second row or the second set of differences. هلا to find b, you do 3a plus b equals to the first difference. When I say first difference, I mean the first number we get in this first set of differences. And then to find c, we do a plus b plus c equals to u1. u1 is the first term, because u is a name, okay? So if we go back to our sequence over here, u1 is like the position of the number. So 11 is the first number in the sequence. So 11 would be u1, or in this case, because the name of the sequence is v, 11 would be v1, okay? This number, this letter over here, it's just a name. It has no meaning. It's not a variable. The second number is going to be v2. Third number is going to be v3. So when we say v1, we mean 11 in this case. Now we see what they want us to find. They want us to find a, which if we go back to the general rule, a is the first number. So to find a, we do 2a equals second differences. If you notice, it's a quadratic sequence. Quadratic sequence, the second set of differences, when we subtract it for the second time, okay, the second set of differences was all equal. It was all equal to 4. So that means the first number in the second set of differences is 4. So 2a equals 4, a is equal to 2, okay? They try to trick us here. They say that what is b? When you see b, that doesn't mean you automatically do 3a plus b equals first. No, because you go back to the general rule, okay? If you go back to the general rule, b is the last term in the sequence. So b is actually c, because remember, quadratic formula is 2a plus bn, 2n minus bn, an squared plus bn plus c. So the last term is c. So what they actually want us to find is c, not b. The equation for c is a plus b plus c equals u1. Or in this case it's v1, because the name of the sequence is v. A, we found it, it's 2. B, we need to find it. C is what we're trying to find. And then v1 is 11. If we go back to the sequence, the first number there is 11. Now to find b, we do 3a plus b equals the first difference. The first difference is the first number we get in the first set of differences. So if we go back to this one, the first set of differences is 15 minus 11, 4. So the first number in the first set of differences is 4. So 3a plus b is equal to 4. A is 2, so 3 times 2 plus b is equal to 4. 6 plus b is equal to 4. B is equal to negative 2. Okay, so 2 plus negative 2 plus c is equal to v1. v1 is 11, so equal to 11. 2 plus negative 2 cancels out, so c is equal to 11. Okay, now we have a new sequence. We need to check if it's linear, cubic, or quadratic now. They told us to name the first set of differences u and the second set of differences v. Okay, so t is 6, 4, negative 4, negative 24, negative 62, negative 124. and it's an infinite sequence. Infinite means it doesn't end. So they told us to name the first set of differences u. So u is equal to 4 minus 6, which is negative 2, negative 4 minus 4, which is negative 8, negative 24 minus negative 4, which is negative 20, negative 62 minus negative 24, which is negative 38, negative 124 minus negative 62, which is negative 62. Okay, and they told us to name the second set of differences v. We have to make a second set of differences because the first set was not constant. Since the first set isn't constant, there's no way this is linear. So now we do negative 8 minus negative 2, we get negative 6. Negative 20 minus negative 8, negative 12. Negative 38 minus negative 62, we get 24. Oh, negative 38 minus negative 20, my bad. You get negative 18. And then negative 62 minus negative 38. You get negative 24. So the second set of differences was not equal either. This is the first, this is the second. So the second set of differences was not constant either, so we have to do a third set of differences. Okay? So we subtract now. Negative 12 minus negative 6, we get negative 6. Negative 18 minus negative 12, we get negative 6. And then negative 24 minus negative 18, you get negative 6. So the third set of differences was equal, was constant, which means this is a cubic sequence. So the sequence t over here, our original sequence, is cubic. Halla v, if we go to v is the second set of differences, right? This if v was a sequence, if we consider v its own sequence, v is the second set of differences. If we consider it its own sequence, then when the first time we subtracted after v, it was constant. Since the first time we subtracted after v was constant, that means v is linear. The original one, t, is cubic, because we had to subtract 3 times. But v, since we only had to subtract 1 time after v is linear, and t is cubic. And here they're just checking. V is equal to negative 6, negative 12, negative 18, negative 24, like they said. And u is equal to negative 2, negative 8, negative 20, negative 38, negative 62, like the options. The difference between any two consecutive terms of v is equal to negative 9. No, we got negative 6, not negative 9. And t is quadratic? No, because we checked and t is cubic. We had to subtract twice, not 1 time. Okay, the general term of a cubic formula is, a cubic sequence is an cubed plus bn squared plus cn plus d. Okay, so here we have, they gave us the general rule, they want us to fill in the blanks. They gave us A already, they want B, they want C, and they already gave us D. So in a cubic sequence, to find B, we have to do 12A plus 2B equals second difference. So this just goes for any, like these are just formulas to use, they always work. If you want to find B, you do 12A plus 2B equals second difference. So we go to the second set of differences, which is V. Okay, we go to the second set of differences. The second set of differences is V. the first number in the second set of differences is the second difference. So the first number in the second set is negative 6. So 12a plus 2b is equal to negative 6. A, they gave it to us here already. A is negative 1. So 12 times negative 1 plus 2b is equal to negative 6. And you can also check for A using the equation for A, which is 6a equals third difference. Third difference, yani the first number in the third set of differences. Or you can just use it as they gave us. You would get the same thing. So 12 times negative 1 is negative 12, plus 2b is equal to negative 6. Negative 6 plus 12 is 6. So 2b is equal to 6, and then b is equal to 4. 3, what was that? 3. So 6 divided by 2 is 3, so b is equal to 3. Now, to find the third number, which is c, to find c in a cubic sequence, you do 7a plus 3b plus c is equal to first difference. So a is negative 1, b is 3, c is what we're trying to find. The first difference is we go to the first set of differences, which is u, and the first number in the first set of differences is the first difference, which is negative 2. So the first difference is negative 2. We solve the equation. 7 times negative 1 plus 3 times 3 plus c is equal to 2 plus c equals to negative 2. C is equal to negative 2 minus 2. Negative 2 minus 2 is negative 4. They already wrote the negative sign for us. So,
Your journey to creating stunning works of art starts here. Whether you're a beginner or...
They already wrote the negative sign for us. So, to get B, for C is negative 4. They already wrote the negative sign, so all we have to write is 4. And we don't need to find D because they already gave it to us. But the formula to find D is A plus B plus C plus D is equal to U1, which is the first term in the sequence. Okay, question 3. Another sequence. So we check if it's linear, cubic, or quadratic. They didn't tell us to name anything, so we can just name it first difference, second difference, and third difference if there's even gonna be. So negative 1 minus negative 7 is 6. 5 minus negative 1 is 6. 11 minus 5 is 6. 17 minus 11 is 6. 23 minus 17 is 6. So that means that the first set of differences is equal, which means it's a linear sequence. So the difference between any two consecutive terms of v, which is the original equation, the original sequence, is constant, which is true, and it was equal to 6, it's true. Equal to negative 5, no, it was equal to 6. Not constant, no, it was constant. Is linear, we check that. Not linear, it's not, because we checked and it was linear. They want us to find the value of a. The general rule for a linear sequence is un equals an plus b. So to find a, you don't have to solve for anything. A is equal to the difference. Okay, so the difference, we got it was 6, so a is just equal to 6. Okay, and b is, to find b, you do u1 equals a plus b. u1 is just the first term in the sequence, a is 6, and then b is what we're trying to find. The first term in the sequence was negative 7. Okay, so we just replace it in. Negative 7 equals 6. Negative 7 equals 6 plus b, so b is equal to negative 7 minus 6, which is negative 13. Okay, this is something called sigma. Now, sigma, some calculators have, you can just put it in directly, some don't, but either way you need to know how to solve it in case it comes written. To solve for sigma, basically, let's say you have okay, let's say you have this. Okay, what does anything mean here? So this number over here is the beginning of the values that you are going to put into the variable. So it's telling you that from 1 until 4, so 1 until 4 is 1, 2, 3, 4. So from 1 to 4, you're gonna substitute each number into the variable, and then each number you get, you're going to add it together. So what I mean by this is they're telling you n is equal to 1 to 4. So n is equal to 1, 2, 3, 4. Okay, so we substitute n. 2 times 1, 2 times 2, 2 times 3, 2 times 4. Okay, and we get the answer of each one. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. These are not the answer for sigma. Sigma is the sum of all these numbers you get after you substitute each n into the variable. So the sum, we add up each answer. 2 plus 4 plus 6 plus 8, you get 20. So the sigma is 20, okay? Let's say the range is much bigger. Let's say instead of 1 to 4, it was 1 to 100, like in this one, okay? They will give you a way to solve it. But first, before we get to that, when you have an equation into sigma, okay? Like for example, you have a plus b, okay? You can't solve it like this, okay? Because you have two variables, okay? And to solve it, you need to do sigma of a separately. When I say n and m, I just mean like these numbers over here, the range, the beginning number and the last number. I'm just putting them as symbols for the range. You need to do sigma of a plus the sigma of b, okay, separately. I'll show you what I mean by this now, but you have to separate it into each term on its own. Hella, if you have, for example, a number multiplied by a variable, like 2n, okay, like the example I just showed you. When you have a number multiplied by a variable, you do the number, you bring the number outside of the sigma, you do the sigma of the variable, and then you multiply the number by the sigma of the variable. So this question has that, so I'll show you an example using the question. And then last thing, if you have a constant, okay, sigma of a constant. By constant, I mean like just a number, like for example 2. There's no variable involved. So what do? There's no variable to substitute into. So when you have sigma of a variable, you do m minus n plus 1 times the constant number, which in this case is 2. M is the number on top over here. So in this case it's 100. Minus n is the number on the bottom over here. So in this case it's 1. Plus 1 times 2. Okay? And then the number you get is the sigma of the constant number. Hella, to solve this one, okay? The range is from 1 to 100. So what you're supposed to do is substitute each number in 1 to 100 into this, and then add up each one. But that's going to take forever because you have 100 numbers. So what do? First of all, you spread the 10 over. You get sigma is equal to 30j, 10 times 3j, plus 10 times 1 is 10. So 30j plus 10, okay? You have two terms you're adding together, okay? When you have two terms you're adding together, you have to separate it. So you do sigma of 30j plus sigma of 10. Okay, هلا I said when you have a number multiplied by a variable, you bring the number outside. Okay, you bring the number outside, so then it becomes 30 times sigma of j plus, when you have a constant, okay, just a number, no variable, just a normal number, you do m minus n plus 1 times the number, which in this case is 10. So m is the number on top, which is 100. N is the number on the bottom, which is 1, so minus 1, plus 1 times 100, times 10. Okay, so it will be 100, 100 minus 1 plus 1 times 10 is going to be 1000. Okay, now sigma of j. How do you find sigma of j? Okay, we said, let's say you can't put it into calculator. Let's say you have a written part. You can't just add up each number until 100. They gave you a way to find sigma of j. They told you the sum of the integers. By integers they mean j. Sum of j is k times k plus 1 over 2. So they told you sum of j is k times k plus 1 over 2. Sum of j is sigma of j, because sigma of j, if you substitute each number into j, you're not going to solve anything. You're just going to get j equals 1, j equals 2, j equals 3. And then when you add all these numbers, that's your sigma, right? They told you sum of j, sum of each number in j is k times k plus 1 over 2. So they basically told you the sigma of j is k times k plus 1 over 2. Okay, so now we substitute. We get 30 times k plus 1 over 2 plus 1000. But now we have a problem. What's k? K is the number on top of the sigma, okay? So we substitute again. 30 times k, which is 100, times k, which is 100 plus 1 over 2 plus 1000, okay? So solve this into calculator. 30 times 100 times 100 plus 1 over 2 is going to give you 15,000 or 151,500. Okay, plus 1,000, you're going to get 152,500,000. Okay, so when you have a, don't forget to multiply 30 by the sigma. So you bring when you have a number times a variable, you bring the number out and do the sigma of the variable on its own. If you have a constant on its own, you do m minus n plus 1 times the constant. If you have a equation, you separate it. Like if you have 30j plus 10, you do sigma of 30j, sigma of 10 on its own. Those are just the rules for sigma. Okay, they gave us this sequence, okay? N is just the number of the sequence, so n is what we're substituting, okay? So they told us qn is equal to 2 minus 2 qn minus 1. So they told us n was 2, so we substitute 2 into n. q2 is going to be 2 minus 2 times q. N, we said we substitute 2 into n, so n becomes 2 minus 1, which is q2 is equal to 2 minus 2 q1, because 2 minus 1 is 1, so q1. They told us q1 is negative 4, so q2 is equal to 2 minus 2 times negative 4. 2 minus 2 times negative 4 is 10, so q2 is equal to 10, okay? And then they want the value of q4, so we solve, okay? We substitute 4 into n. q4 is equal to 2 minus 2 q4 minus 1. which is equal to 2 minus 2 Q3. We don't have Q3, so we need to solve for Q3 now. Q3 is equal to 2 minus 2 Q3 minus 1. So 2 minus 2 Q2. Q2 we found it in the previous question. Q2 is equal to 10. So 2 minus 2 times 10, because Q2 is equal to 10. 2 minus 2 times 10 is negative 18. So Q3 is equal to negative 18. So now we substitute 2 minus 2 times negative 18. Sorry. 2 minus 2 negative 18 is equal to 38. So Q4 is equal to 38. Okay, they give us another sequence now. They want the value of Q3, so same thing, substitute 3 into n. Q3 is equal to 2 times 3 squared minus 3 plus 2. Put this into calculator. You get 17. So Q3 is equal to 17. Okay? And then they want the value of Q1 plus Q10. So Q1 is 2 times 1 squared minus 1 plus 2. And then Q10 is 2 times 10 squared minus 10 plus 2. So put each one into calculator. 2 times 1 squared minus 1 plus 2 is 3. And then 2 times 10 squared minus 10 plus 2 is 192. They want Q1 plus 10. Q1 plus Q10 is 3 plus 192, which is 195. Consider the finite sequence U. Finite just means it finishes, okay? Infinite is when it has dot 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 at the end and there's no number at the end. Infinite means it goes on forever, it doesn't finish. Finite means it finishes. Here we can obviously see that it finishes, so it's a finite sequence. They want U6 minus U2. Remember when they say U6, or like the name of the sequence, and then 6, that means the position, okay? So here 3 is the first number, so 3 would be U1, okay? So U6 would be 1, 2, 3, 4, 5, 6. So this would be U6. U6 is 49, okay? Minus U2 is the second number, okay? Its position is the second number. So 1, 2, U2 is 5. So 49 minus 5 is 44. Okay, sigma notation again. Here we have a very small range. When you have a small range, 0, 1, 2, 3, 4. Okay, this is just 5 numbers. When we have a small range, you can just solve it normally. We don't need to do everything. Because they didn't tell us what, they didn't give us a way to find the sigma of the variable. In the other question, they told us that this is the sigma of the variable. But in this question, we don't have the sigma of the variable. They didn't give us anything, they just gave us the equation itself. So it's a very short range, so we can just substitute it in. So there's 5 values for m. 0, 1, 2, 3, and 4, from 0 to 4. So we just substitute 3 times 0 squared minus 0, 3 times 1 squared minus 1, 3 times 2 squared minus 2, 3 times 3 squared minus 3, 3 times 4 squared minus 4. 3 times 0 squared minus 0 is 0. 3 times 1 squared minus 1 is 2. 3 times 2 squared minus 2 is 10. 3 times 3 squared minus 3 is 24. 3 times 4 squared minus 4 is 44. So now we add up all the numbers. 0 plus 2 plus 10 plus 24 plus 44. Sigma is equal to 80. Okay, and then now we have this equation over here. So when we have more than one term added together, subtracted together, we separate it, okay? So we do sigma of 10k squared plus sigma of k plus, or minus, because there's a minus here, minus sigma of 10, okay? So when you have a number multiplied by a variable, you bring the number outside of the sigma. So 10 times sigma of k squared plus sigma of k minus, when you have a constant, you do m minus n plus 1 times the constant, which is 10 in this case. M is the number up, so 8, minus n, which is the number down, 1, plus 1 times 10, which is 8 minus 1 plus 1 times 10 is 80. So, and in the question up, they told us that sigma of k, k, which is what we have here, is 36. So we just substitute. And they told us sigma of k squared is 204, which is what we have here, sigma of k squared. So we just substitute also. Don't forget about the 10 though, we're still multiplying by 10. So 10 times 204, 10 times sigma k squared is equal to 2040 plus 36 minus 80. Put it into calculator, you get 1996. And that's it for 6.1.